Here are some vocabulary terms to get us started. First, similar. Similar is having the same shape but different size. Similar figures have corresponding sides proportional and corresponding angles equal. Corresponding are objects that are in the same position in a shape. Proportional is having the same scale factor. And finally, scale factor is the ratio of the corresponding sides. So we're going to start talking about our final type of transformation, which is a dilation. Recall that a dilation is when you resize an object by making it bigger or smaller. To talk about dilations, we have to talk about similar figures and scale factors. So that's what we're going to be talking about today. Similar figures are figures that have the same shape, but not necessarily the same size. They will also have the following properties. Corresponding sides will be proportional. That is, the ratios of the corresponding sides are equal. So just to kind of elaborate on that, that means that if one pair of sides from one shape to the other increase by a factor of 2 or 3 or 2.5, whatever the scale factor is, then all of the other pairs of sides will increase by that same scale factor. The second property that they have to have is corresponding angles are equal. Corresponding angles are in the same position, so from one shape to the other, angles that are in the same position should stay equal. Let's look at an example. We have a couple squares here. The first square has side lengths of 2 centimeters for all sides, and the second one has side lengths of 4 centimeters for all sides. These two shapes are similar because they're the same shape, they're both squares, but they're different sizes. You can hopefully see that it increases from 2 centimeters to 4 centimeters. And when we talk about increasing by some type of factor, it is always multiplying by something. So here, to get from 2 to 4, we would have to multiply 2 by 2, or double 2, to get 4 centimeters. So these figures have a scale factor from the smaller shape to the bigger one of 2. They show you the pairs of sides that are corresponding by showing you AB, which is the bottom side of the bigger square. Divide that by PQ. You can also divide BC by QR, CD by RS, and DA by SP. And for all of those, when you divide them, you should get 2. Another way to show that the scale factor here is 2. And then these are both squares, so all of the angles will be 90 degrees or right angles. So of course, angle A is equal to angle P. Those are in the same position in each square. Angle B is equal to angle Q. Angle C is equal to angle R. And finally, angle D is equal to angle S. So therefore, the squares are similar figures because their corresponding sides are proportional and their corresponding angles are equal. The smaller square PQRS has been multiplied by 2 to obtain the new figure ABCD. The number 2 is what is referred to as the scale factor. Whatever you have to multiply by to get the other shape is the scale factor. Let's look at some practice questions together. So the directions say to determine whether the polygons are similar. Well, we don't have any information about angles here, so the way we're going to determine if the polygons are similar is we're going to verify that the sides are proportional. Remember, proportional means that they increase by the same scale factor. The scale factor is what you multiply by. So we want to make sure whatever we have to multiply 7 by, for example, to get 21, since those are in the same position, and the same thing we have to multiply 2 by to get 6, 14 by to get 48, and again 7 by to get 21. So we will do this and verify it by division. So first I'm going to start with these two sides. Those are in the same position. So 21 divided by 7 is 3. So that means to get 7 to be 21, we would have to multiply by 3. Obviously, we know those are both going to be true. Let's now do 14 and 48. Now notice I divided 21, which is the number from the right side figure, by 7, which is the one from the left side figure. So since I did 21 on top, I need to do 48 on top for the next one, divided by 14. And 48 divided by 14 is 3 point, I'll go 2 decimal places, 4, 3. So already right there, I can see that these first two pairs, the 7 and 21s, those had a scale factor of 3, but the 14 and the 48, it got bigger by 3.43. So since these do not have the same scale factor, these sides are not proportional. So are these similar? No. So we'll just say not similar. And once you have either verified that they're all the same, or if you notice a difference, then you can make your conclusion and you're finished with the problem. So let's go ahead and look at number 2. So number 2, we'll start with 7 and 14. I'm going to divide 14 divided by 7. 14 divided by 7 is 2. So those two go together. We have another 7 and 14, so obviously we know those are going to be true also. And then we have a 2 and a 2. So 2 divided by 2 is actually 1. So are these similar? No, since we noticed a difference. Now keep in mind, the way they are going to be similar is you'll have to divide all side lengths. All of the results of your division need to be the same number for them to be similar and have the same scale factor for all the sides to be proportional. Let's go ahead and look at our next examples. The directions here say each polygon pair is similar. So we know that the side lengths are proportional since they are similar. Remember, proportional means that the side lengths have the same scale factor. What it wants us to do is to find the scale factor of the smaller shape to the bigger shape. So when we find our scale factor, we need to make sure that it represents a scale factor that indicates that something is getting bigger. To do that, you need to make sure that your scale factor is bigger than 1. A scale factor bigger than 1 will indicate that something is getting bigger. So to find the scale factor, you are going to pick any pair of corresponding sides from your shapes. So as long as they are in the same position, it should be a corresponding pair. So I'm going to pick the pair 48 and 60. These two sides are in the same position in the figure. Now we need to divide these to figure out what factor we would multiply 48 by to get 60. So again, we need a scale factor that indicates something is getting bigger. So to do that, we need to take 60 and divide it by 48. You can represent your answer as a reduced fraction or a decimal. 60 divided by 48 as a reduced fraction is 5 over 4. As a decimal, this would be 1.25. So all of our pairs of sides, if you multiply the smaller side length by 5 over 4, 1.25, you should get the side length on the bigger figure. Also notice that our scale factor 1.25 is bigger than 1. Let's go ahead and look at our final example, number 4. So to figure out the scale factor here, we're going to pick any pair of sides. So I'm going to pick the pair of sides 3 and 9. Remember, this is from smaller shape to bigger shape, so our scale factor should indicate that it is getting bigger. So I need to divide 9 by 3, which gives me a scale factor of 3. So that is our answer. Once you get your answer, you can also pick any other pair of sides and verify. For example, our only other pair is 12 and 36. So 12 times our scale factor 3 does give us 36. So you can verify and see that it works with that also. Thanks for watching this video. You now need to go onto Edulastic and complete the similar figures homework assignment. Also, remember, if you have any questions, please do not hesitate to ask. I will be happy to help you.